Astronomers have studied exploding stars for decades, but every once in a while, one appears that completely changes the conversation. Back in 2017, scientists spotted a supernova called SN 2017 EGM in the galaxy NG, C 3191, about 440 million light-years away, near the constellation Ursa Major. This wasn't just another bright flash in space. By July of that year, the explosion had become brighter than every star in its entire galaxy combined. At first, astronomers could only study the visible light coming from the blast. But years later, data from Fermi Gamma-ray Space Telescope revealed something much more dramatic happening behind the scenes. The telescope detected gamma rays coming from the same region of space between July and October 2017. That may not sound huge at first, but this was the first solid detection of gamma rays from a superluminous supernova like this one. That discovery gave scientists a major clue about what was powering the explosion. Researchers led by Fabio Acero believe the supernova created a magnetar. A magnetar is an incredibly dense neutron star that spins hundreds of times every second, while producing a magnetic field far more powerful than almost anything else in the universe. According to the team, this newborn magnetar pumped out streams of high-energy particles like electrons and positrons. Those particles smashed together inside a giant cloud surrounding the collapsed core, creating intense gamma rays. In the early stages of the explosion, the thick outer shell of debris trapped all that energy inside and converted it into visible light. That's one reason SN 2017 EGM became so unbelievably bright. Then, after about 3 months, the expanding debris started cooling and thinning out. That allowed some of the trapped gamma rays to finally escape into space. And that exact leak is what Fermi managed to detect for the first time. To test the idea, scientists built computer simulations that recreated both the timing and the brightness of the explosion almost perfectly. Researchers including Indrek Verm and Brian Metzger worked on the models, while experts from Louisiana State University helped analyze the data and interpret the supernova itself. What makes this discovery especially exciting is that superluminous supernovae are already extremely rare. These explosions are powerful enough to outshine entire galaxies, yet scientists still haven't fully agreed on what causes them. One theory pointed to magnetars, while another suggested the explosion was interacting with clouds of gas released by the star years earlier. Now, thanks to the gamma-ray detection from SN 2017 EGM, astronomers finally have much stronger evidence supporting the magnetar explanation. Instead of only seeing the light reflected from the outer layers of the blast, scientists were essentially able to peek directly into the heart of the explosion itself. Out of nearly 400 superluminous supernovae discovered over the past 2 decades, this one may end up being one of the most important. It's giving astronomers a clear understanding of how some of the most powerful explosions in the universe really work, and it could completely reshape future studies of dying stars.